Hi and welcome to Geeks for Geeks. Can I have a quick +1 in the chat if I'm visible as well as equally audible? Then we would right away start. Let me just see if I am visible now or not. I should be visible by now. Okay, fair enough. Thanks a lot, Clever Coders. Thanks a lot, Prem Prakash. We have many people waiting here. Can I have a quick +1 from them so that I know that yes, they are now ready to start and so that I can just start. Still, we would just wait for half a minute and then we would start right away. Okay, so let me just turn on my timer itself. Countdown should be of 0.5 minutes. Okay, thanks a lot, Yash Mitra. Thanks a lot. Thanks a lot, Chirag Singh. Okay, so how was the contest today? Abhijit Kumar, thanks a lot. How was the contest today? Were you able to solve any questions? The question was kind of linked list specific type. Satyendra Kumar. Okay, thanks a lot. Thanks a lot. Okay, so let's start today. So we would be starting with the first question itself, that is intersection of Y-shaped linked list, and then we would be moving towards flattening a linked list. Okay, rank was 71. Yash Mishra, congratulations, brother. Okay, got both problems, no penalties. Okay, that's great, John. You are improving. So let's start with the first question itself. First question was a bit of an observation. Okay, I would tell you how. Given two singly linked lists, singly linked list means that there would be one link. Okay, singly link means one link. Doubly means double link. Okay, of size n and m, and n and m can be equal, n and m cannot be equal. Write a program to get the point where the two linked lists intersect each other. Okay, so you need to write a program where that two linked lists intersect each other. So how it can be visualized? It can be visualized in such a way that suppose this is 3, then the next pointer would point to 6, then the next pointer would point to 9. Okay, now suppose the next one, this is 10, now then both would point to the same thing, that is 15, and then it is 30 itself, and then it's null. Okay, so this is the question itself. So where is the point that they are intersecting? The intersection point is this point. That is why the answer to this is 15 itself. Okay, fair enough. Let's move to the next question. So the next question is, first we have 4, then we have 1, and here we have 5, here we have 6, here we have 1 itself. Then they both point to the same thing, that is 8, and then 4, and then 5 itself. Last points to the null, whatever it is, and the intersection point is this point. That is why the answer to this also is equal to 8 itself. Fair enough. Now there is a clear observation about this. Okay, I would try to visualize the observation. The first observation is length after intersection is equal. Okay, this is the only observation that you need. Rest, this is the implementation problem, to be honest. Now if I just try to visualize this, suppose the first linked list is like this and the second linked list is like this. Okay, then after this the both points are like here. Okay, so if you can just observe, suppose this is the first node, this is the second node, this is the third node, and this is the fourth node, this is the fifth, this is sixth, this is seventh. So if you just observe this, what you can observe is, suppose this, suppose this is the first node, then this is the second node, this is the third node, this is the fourth node, this is the fifth node, this is sixth, this is seventh, this is eighth. Okay, why I told that after the intersection the number of the length is equal? Why? Because after the intersection of this, this linked list has also 3 nodes after intersection. This linked list has also 3 nodes after the intersection. This is the first node, this is the first node itself, this is the second node itself, this is the third node itself. This is why it is said that the 3 nodes are equal to that. Okay, fair enough. Now, before that, whatever it is, okay, before that, whatever it is, we don't care about it. Okay, just a second. Yeah. So, now, एक चीज करते हैं. Okay, हमने बोला, okay, suppose me and my friend is walking. Okay, suppose my friend is coming from a faraway place and I come from a nearby place. Okay, and we want to reach the same destination. So he tells that at that point of time we would collide and हम उस destination तक दोनों साथ में पहुंचेंगे. Okay, so उस collision के बाद वो distance साथ में जाया जाएगा. Okay, हाय मधुकर. Okay, उस intersection के बाद वो distance साथ में जाएंगे वो लोग. तो एक काम हम लोग ये भी कर सकते हैं कि जहां तक दोनों का डिफरेंसेस है, सपोज ये इतना है, ये इतना है, तो ये वाला डिस्टेंस हम पहले ही कवर कर लेंगे. ये चीज हम पहले बिफोर हैंड कवर कर लेंगे. फिर ये दोनों डिस्टेंस को ऐसे जाएंगे. ठीक है, अब यहां से हम लोग सेम जाना शुरू करेंगे. ओके, और जिस पॉइंट पे दोनों इक्वल होगा वो पॉइंट ऑफ इंटरसेक्शन हो जाएगा. पहला इक्वल हो जाएगा तो पॉइंट ऑफ इंटरसेक्शन हो जाएगा. If I just tell this in English, okay, suppose what we do is if we just count the difference of their length, suppose 1, 2, 3, and suppose this 3 is already covered. If I just remove this 3, okay, if I just remove this 3 and I start from this point, then we both walk the first one. This is the second one, this is the second one. At this point, both the node would be equal. At this point, the first point. At the first point where both the node are equal, we need to return that node. And this is quite easy. Yeah, I'm telling the same thing in Hindi as well as in English. Don't worry about that. Okay. So, this is the time when if we count the number of distance. Okay. So, what we need to do is, first we want the count of both the linked list. So what we can do is, suppose this is 1, this is 2, this is 3 and this is 4. So what we can do is, we can start from the first node itself. Then we take this node and we move to this side. Then we take this node, we move the node to this side. Then we take this node and we move it to this side. And how many nodes we would traverse? Every time we get a valid node, we would just keep incrementing the count. And after a certain point, we would know that yes, it is 4 itself. After this, it would be null. So when it would be null, this is not true. So this won't be executed and we would directly return that. Okay, fair enough. Clever coders, what have you written? I don't know actually. Okay, by the way, I'm not very much inclined towards Hindi, but the thing is that when I was in my initial days, I used to think that someone might have explained me in a language in which I'm more familiar. That's why I repeat the same thing in English as well as in Hindi. That I do, so that people who are good with Hindi can get a better explanation. Okay, fair enough. Still, if you have anything to tell me, just tell me directly. Okay, fair enough. So this is how we are counting. So this is the function to count the number of nodes, and then we move forward to this. First, we are counting the length of the first linked list, then we are counting the length of the second linked list. If the length of the first linked list is more, then we count the difference and we tell that h1, h2 and we keep the distance at this point. If it is d, then it is told that h2, h1 and d. Why is this thing? We always consider that the first linked list has greater length. Okay, the first linked list has more length. This is the reason that we are passing the linked list which has larger length first, and then we are passing the linked list with lower length. See, h1 is greater, length of the h1 is greater, so we are passing h1 first. If the length of the h2 is greater, we are passing h2 first. This is what we are doing. Fair enough? Then what we are doing at this point is that we are first traversing the difference. So if at any point we are hitting the null case, then it means that we need to return -1 because there is no intersection at this point. So we would return -1. Then what we do is C1 is equal to C1 dot. We keep traversing, okay? And then if at any point both the nodes are same, then we return the data of the node. This is what is asked. And we would keep traversing both with similar step. दोनों साथ में आगे बढ़ेंगे. Both would walk the similar distance. And if all this is not true, then we would return -1 at this point. Okay, fair enough. This is what we need to do. Now, am I clear till this point or not? Just quickly tell me. If there is any doubt that is persisting in your head, I would be more than happy to explain you again. Just quickly tell me if there is any doubt regarding the first question itself or not. Then we would move to the next question. But don't keep me waiting. If you just reply me quickly, then we would move to the next question itself. Okay, got both problem. No, I can't solve even of the question, one of the question. Okay, it's absolutely fine. Okay, how much time will it take us to master DSA? Actually, there are a lot of techniques, to be honest. So if you're kind of want to be fluent with DSA, then it would take less than 6 to 8 months. But if you want to master DSA, then it would take a little bit more time. Cut function. Okay, fair enough. Let me just explain the cut function itself. Okay. Yes, is this optimal? I think one pass is not possible. I think one pass is not possible. No, one pass is not possible. So I would just draw this, okay? So because there were people who didn't understand. Suppose this is equal to 6, then this is equal to, then this is equal to 3, 6 and then 9, and this is equal to 10 itself. Then they both merged and this is equal to 30 itself, okay? Now the first linked list has the length how much? 1, 2, 3, 4, 5. So L1 is equals to 5. L2 is equals to 3. L2 is equals to 3. Okay. 5 minus 3 is equal to 2. So D would be equal to 2. Then what we would do is we would traverse this linked list. This is D minus minus. Then D minus minus. Now D is equal to 0 because 2 minus 1 is equal to 1. 1 minus 1 equals 0. Now 0 means false. So we would end at this position. Now what we would do is we would start moving in one step. So if C is not equal to null, C2 is not equal to null. This is not equal to null. This is not equal to null. What we would do is we would come here at this point. After we come at this point, this would become true. That is C1 is equals to C2. Both at the same thing. That is when we would return the data of the first node itself. And we are returning 15 at this point. Why we increment 2 of the node pointers? Yeah, this is the needle, because we would go at a same pace. Okay, where is the implementation for the method cut? This is the implementation of the method cut with a dry run from the sample test case itself. You are most welcome, John. Can I have a quick yes again so that I know that yes, this is done and I can move forward? Just quickly tell me if you have understood now or not. Lavina, Saran, thanks a lot. Thanks a lot. Chirag, Clever Coders. Okay, Clever Coders, are you able to get it? I'm just speaking in English most of the time, okay? Now tell me if you're comfortable. At any point, if you're not comfortable, just let me know. It's absolutely fine. Chirag Singh, thanks a lot. Anve Pakhale, sorry. Anve Pakhale, thanks a lot. What is the time complexity? The time complexity of both is, suppose we are keep traversing both of them. So for the time complexity is it is n plus m, because the length of the first linked list is n and the second is m. But the space complexity is big of 1. Why? Because we are not using any auxiliary space. We are just taking help of the variables, and variables take constant space. So, and constant are ignored in time complexity. That is why the space complexity is big of 1. Ragini, thanks a lot. Aniket, did you get my explanation? Okay, now let's move to the next question. This question is very interesting. Okay, we are given a linked list of size n, where every node represents a sub-linked list and contains 2 pointers. Suppose this is a linked list and it contains 2 pointers, one next to the next node and one a bottom pointer where the node is the head. So this node would act as the head, and this is the next one, this is the bottom one. Now each of the sub-linked list is in sorted order. Okay, so we are given the facts that each sub-linked list is sorted. Okay, this is the first thing. Now flatten the linked list such that all the nodes appear in a single level while maintaining the sorted order. Okay, what you need to do is you need to merge all of them, okay, maintaining the sorted order. Okay, the flattened linked list would be written using the bottom pointer. So you don't need to do like this. Okay, you don't need to do like this. Rather, what you need to do is you need to do like this. Okay, this is what you need to do. Okay, now let's try to solve this problem. So 5, so let's use the white one because it creates a very good contrast. So 5, okay, then 7, then 8. So 5, 7, 8, then 10, 10, then equal to 20, then equal to 30. Okay, now this is how we would merge these two. Okay, if you talk about merging all of them, then it is 5, 7, 8, 10, 19, 20, 22, 28, 30, 35, 40, 45 and 50. Okay, max of n plus m plus common. So time complexity, suppose the linked list, the length of the linked list is same, but there is no intersection. If the length of the linked list is same but there is no intersection, then we would keep traversing both of them, that is n plus m. Okay, suppose there is no intersection, this thing is not there, it is like this. Okay, so if it is like this, then we need to traverse both the linked list. If we need to traverse both the linked list, then it is n plus m. Okay, thanks a lot Aniket Kumar. So now this is how you would. Okay, so now if I just tell you this question in another way, so it can be summarized like this. Okay, merge sorted arrays, merge sorted arrays. Okay, now if this is the question, suppose this is the question, then it is quite clear that we just need to merge sorted arrays together and provide the resultant array. This is what you can do. So you can kind of visualize and link up to the problem using merge sorted arrays. This is what you can do. Okay, till this point we know that we need to link up this question which merge sorted arrays. Okay, now how to do it, Siddharth? That is of absolute importance. Okay, so let me just show you this. Okay, so now suppose this is equal to 5, this is equal to 7, this is equal to 8 and this is equal to 30, and this is equal to 10 and this is equal to 20. Okay, suppose this is array 1 and this is array 2, encircling them with a different color so that I know. Okay, now what can be done is, first I would just check which one is smaller. I know that 5 is smaller, so I would take out 5. Then 7 or 10, 7 is smaller, so I would take out this 7 also. Then 8 or 10, 8 is smaller, so I would take out this. Then 30 or 10, 10 is smaller, I would take out this. Then 30 or 20. 20 is smaller, so I would take out this. Then 30 is small, 30 is left, so we would take out this. This is what I can do till this point. Okay. Now let's move to the implementation. What we would do is we would start with this merging thing. And what I can do is, suppose I just merge this with this, then the resultant of this can be merged with this. Then the resultant of this can also be merged with this. This is what I can do. Suppose there is A1, A2, A3 and A4. So what I can do is, I can just merge A1 and A2. Then I can merge the resultant of these two with this. Then I can merge the resultant of these three with the third one. I can do that. And whatever is coming at the end, I would say that yes, this is the resultant thing. Now the number of like is just 14, but the number of live viewers is much more than that. So if it can you just increase the like counter if possible, please, if possible. Now let us just start with the implementation, and we would take up this example as a dry run. Okay. So now this is the code for the merge itself. Okay, so I would just paste it and then we would keep discussing. Okay, now this is 5, 7, 8, 20 and this is 19, 20 and 50. Okay, fair enough. So yeah, this is it. So now if A is equal to null, then suppose there is at the first place, suppose this is nothing. So we would return this. This is nothing, we would return this. This is what we are doing. Then we are building a resultant one. Now whichever is smaller. So first let's suppose we want to just merge 5, 7, 8 and 30 and we want to merge with 9, 22, 22 and 50. First we take up this 5 itself. So we would say that yes, the bottom is equal to 5. Search more bottom of this. Now which one is smaller? 7 is smaller, so I would take up this. And then we would pass the remaining thing to the again. So 7 is also done. Then 8, then we would take up this 8. Okay. Then it is 30, so we would take up this 19, which is smaller, so 19. Then we take up this 22, which is much smaller, so we take up this. Then it is 30, so we would take up this thing. Then we would take up the remaining, that is 50 itself. Okay. Now till this point this is complete and we are able to merge these two. Okay, fair enough. Now let us just talk about the merge flatten one. We get the root of this. So if any of them is null, we return that. Else what we would do is we would take up the first linked list and we would take up the second linked list. Then suppose this is A, B, C and D. We are taking A and we are taking A's next, that is B. Then A and B is getting linked this. So A and B is now here and now we would take B's next, that is C. So now this would be done. Now this all with C's next, that is D. This is how we would merge all the linked list. Okay. Now tell me if this thing is clear or not. If this thing is not clear, I would be more than happy to explain you again. But you need to tell me if things are clear to you or not. Still, I would have an upper bound to this waiting, that is of 1 minute. So quickly tell me if things are clear to you or not. How to handle the list starting with 19 in the first sample test merging with the current list? Do we traverse them till now again? Okay, how to handle the list starting with 19 in the first sample test case and merging with the current merged list? And how to handle the list starting with 19? Which is the list starting with 19? Okay, 19. Okay, in the first sample and merging with the current merge linked list. Do we need to traverse the merge list till now again and again? Yeah, we need to keep merging it. Suppose we are getting there, if this is small, we would merge it and then we would pass on these two. Okay, I would try to visualize this. Suppose what we are doing is, suppose this is 1, 5 and then suppose this is 7. and this is just 3, and this is suppose 9. So first what we would do it, this is small, so this is small, so we would just write here 1. Okay, then we would pass the remaining 5 and 7 and 3 and 9. Then which is small? 3, so I would just write here 3. Then 5 and 7 and then 9 itself. Okay, now which is small, 5 or 9? 5 is small, so I would just write 5 and remove it, and then I would just write 7 and 9. Which is small? 7, so I would just write here 7, and this is now equal to null, and then 9 is remaining, so I would just write here 9, and this is how we are merging. So every time please explain the merge function code. Can you repeat again, please? Okay, everyone is trying me. Okay, so what are the queries? Flatten function again. Okay, I would explain the flatten function again. This is the flatten function. Okay, please explain in the first sample in the problem description. First sample, which is the first sample? I think this is the first sample. This is quite a bit lengthy. Give me a little bit smaller one. Okay, I would take up this one if you are comfortable. Okay, so now I would keep up both of these. Okay, okay. Now let me start explaining both of them. Okay, okay, fair enough. Now suppose this is 5, 7, 8, 10, 30, and this is equal to 10. Okay, now root is equal to, suppose this is the root. Root is given as 5. Okay, this one. Okay, let me make it a little bit big. Okay, then you would get what I am trying to say. Okay, the first is 5. Okay, this is given as the first one, that is 5, and then root is not equal to null, root of next is also not equal to null, then this root, that is 5, and root of next is equal to 10, we are passing 10. Okay, fair enough. Now this is 5 and this is 10. Okay, now no one is equal to null, so we would come here. Now we would also have a result known as R. Okay, so A of data is less than B of data. Yes, A of data is less than B's of data. So I would just say that yes, 5, and I would replace it with the next. So this is done. Okay, now I would replace it with 7. Okay, now we merge of A of bottom. A of bottom means what? 7. 7 and 10. Now which one is small? 7 is again small. So I would just say yes, the next one is also 7. And I would remove this and I would write 8. And what is the next one? The next one is also 8. So which is small? 8 is small. So I would just write here 8. Okay. And I would say that bottom, A of bottom, 8's bottom is 30. Now which one is small? 10 is small. So I would just remove this 10 and I would write here 10. Now this is equal to null. So if the second one is equal to null, we would return the first one. This is equal to null, we would return the first one, that is 30. So we would return the first one 30. Now we would try to merge this one with the next. So these two are now merged. Okay, these two are now merged. This two is now merged. Now we want to merge this with this. Okay, now 5 and 19. 5 and 19. Which one is small? 5 is 5. Which one? Sorry, not 5 and 19. This one. 5 and 19. Yeah, 5 and 19 would be there. 5 and 19. Which one is small? 5 is small. So I would just write here 5 here. Okay, so I would just remove this again. That is how we are merging. Then I would just write 5. 5 is small, I would just write 5. Then which one is small? 7 or 22. 7 is small. That is how we are merging. Okay, now moving forward with the flattening one. Okay, now flattening one is like this. Okay, suppose what is done here is that I would just explain it. Okay, yeah. So if one of them is equal to null or there is no next possible, suppose उसके आगे कोई sorted list है ही नहीं, suppose I am having no next sorted list, then I would return the first list itself. Suppose there is only one array, then I would return the first one itself. Now if that is not the case, we would return the root head of the first list, and then we would say that we would send the second array also, first and second array. Now first and second array got merged to the root, and then we would say that roots next with this one only. That is what we would do. Okay, now Subhangini, thanks a lot, clear coders, thanks a lot Vansh. If it would exceed, my point was that I think we would exceed n into m time here, don't we, if we traverse through our purse medium again and again? Yeah, this is the case. Yeah, but the time complexity is n cross m. So the intended, the expected time complexity and time complexity of our solution is absolutely the same. So we are not worrying too much on this. Okay. Thanks a lot. So I would waste for the last 1 minute. Okay. Thank you so much, sir, for an amazing explanation. This was first time here. Hope to be here every Sunday, and I hope to be here every Sunday too. Happy Sunday, by the way, Vanshrana. Okay, so I would wait for the last 1 minute, and if I see no doubts coming in, I would turn off the session after 1 minute. Now this is an open forum, you can ask me anything you want, okay? Just no personal questions. Most welcome, Rakesh Mond. By the way, Ayushi Rana Saha, are you able to understand? You told me that you are not able to understand the flatten function. Now are you able to understand? Can this be optimized as can this be optimized? If we just talk about this, it can be optimized, but we would be, thank you so much, learned some new things today. You are most welcome, John. By the way, John, you are from India or you are from outside India? I just wanted to know. It's completely fine if you don't want to tell me. Will this live video be available on channel? Yes, this video would be live. This video would be available on channel. After the stream, you would find them in past stream, and then tomorrow you would find them in the uploads. That is what I have observed from the past previous sessions. Okay. Okay, so that's it for today. Thank you and have a nice day. Good night, everyone. Keep hustling.